let's understand the importance of a trigonometry using this simple scenario here. So the whole concept of a trigonometry is all about a distance, right? A distance. Let's say you are here, right? This is your house, and then your friend lives here. So we want to know the distance between the two of you, where you are and then where your friend lives, right? And then here's another one. Assuming this is your college or maybe this is your school, right? So we are forming a triangle. So where you are, where your friend stays, and then where your college is, right? So this is what a triangle. The picture is what a triangle, right? So the idea of a trigonometry helps us to determine the distance between the locations, right? So let's say you are here, your friend is here, and your school here. The trigonometry, this guy here, helps us to determine the distance between them, as well as the angle. What I mean by the angle is that where you are basing, right? So where you are basing this portion here. So the trigonometry helps us to know two things, right? So for basic understanding here, it helps us to know two things. That is the distance between the two of you, or maybe the three of you, or more than, right? And then as well as the angle where you are basing. Is that okay? So that is one important, the main importance of a trigonometry. Now let's see how to use them, and then how to apply it to solve some of a real life problem here. But now the trick here is that the first thing first, right? So basically in this video we are solely going to talk about a 90 degrees. What I mean by the 90 degrees here is that if you are here, your friend lives here, you can see that this line is a straight line. So what I mean by a straight line is that the road from your place to your friend's house is straight, right? There's no curve. Is that okay? There's no curve. Is that okay? So that is a straight line from here to here. And then assuming where your friend stays to the school is also another straight line from top to down. Is that okay? So here from the school, that is a straight line. There's no curve. Is that okay? There's no curve, a straight line, and where you stay to your friend's house, there's also another straight line. So if that happens, we see that the joint here, your friend's place here is 90 degrees. Is that okay? This is 90 degrees. So if one side of what this shape here, the triangle is 90 degrees, then we call it a right angle triangle. Is that okay? So the first thing is that you must make sure that this triangle here is a right angle triangle. And then let's see the tools that we can use to solve the distance and the angle when your dimensions, right, your locations, one side of your locations forms a right angle triangle. So this is one trick here you must make sure that you understand perfectly. Now if it is a right angle triangle, then these are some of the basic trigonometry that you have to use. Right, so these are some of the things that can help us to determine the distance and the angle between your locations. So the first one we call it sine, and then followed by cosine, and then tangent. These are just a new name, right? So if you are new to trigonometry, so these are some of the tools that we can use. Is that okay? So you can the same way you use your cell, your phone to make a call and other stuff. This here we are going to use this guy here, these three guys here, to determine the dimensions and then the angles between the three of you. Now the meaning of this thing is a sign of where you are is very, very important. Is that okay? Where you are located. So assuming you are here, right? Assuming you are here. So if you are here, then maybe this is where you are hiding. Is that okay? So you are hiding at this portion here, right? So if you are here, you can see that when you lift up your head, this will be your opposite, right? So when you lift up your head, this guy here, this line here will be your opposite. So if you are in your house, you lift up your head, you can see that you are just looking at the distance between your friend and the school. Right, so this guy here will be your opposite, right? So where you are, it's very, very important. Where you are matters here. So if you are here, so this guy will be your adjacent, right? So I think these are some of the English words you have to pay attention to, right? So if you are here, the tan here will be your adjacent, right? So the name of this guy here, we call it a hypotenuse. Is that okay? So where you are matters here. So what will happen if you are here? Make sure that you write your answer. So which line will be your opposite and which line will be your adjacent, as well as the hypotenuse. Is that okay? So but for this video, assuming you are here, so this is where you are. So if it's starting from here, it's very, very important. If you are at that place, then the sign of where you are will be equal to the opposite of a hypotenuse. So this is one trick here. So sine of where you are is equal to opposite of our hypotenuse. So mathematically, so you say sine x, the s here is where you are. Is that okay? So sine s is equal to opposite of a hypotenuse, right? Now we have another one. The second guy is cosine. Okay, if that is a cosine, we call it a cosine. So what does it do? So the cosine here is what? Cosine of x. So if you want to find the cosine of s, so let's say you are here, then you want to find the cosine of s, then how can you do that? So the cosine of s will give you what? The adjacent and then over what? Hypotenuse, right? Now that we are familiar with these three guys, the opposite, adjacent, and the hypotenuse. So the cos of the x will give you the adjacent over hypotenuse, and then finally that is the tangent. Tangent will give you opposite over adjacent. Is that okay? So these are the three guys we use to determine what the distance between the three of you, your friend, as well as your college, right? Okay, maybe you can assume that each one goes for one of the lines, so that's just an assumption. But make sure that you watch the video to the end, whereby you solve a pure exams question. Now, once again, if your triangle, the triangle between the three of you, gives you what a right angle triangle. What I mean by the right angle triangle is that one side of the triangle forms a 90 degree. Then assuming here we are told that here is 2, and then here is 3. Is that okay? If you are given two sides, let's say the distance from where you are to your friend's place is 2 kilometers, assuming, and then where your friend lives to the college, give us another 3 kilometers. They say you should find this guy, the third one, right? The third one. So the two that you are going to use, if they give you this two side, it can be here. Is that okay? But here, assuming you are giving this guy here and this guy here, right? So they say you should find this here. The two that you are going to use to do that, in addition to this trigonometry here, we call it Pythagoras rule, or the Pythagoras theory. Is that okay? So this is the tool that we can use to determine if you are giving what two side of, pay close attention. I say two side of what, the dimension, right? So the distance from here to here, and then that to that. But the trigonometry, what this trigonometry does is that you are giving one of what, the angle where you are basing. So let's say you are your room here. Is that okay? So that differs from the Pythagoras theory. The Pythagoras theorems give us the dimension outside. They give us the two dimensions, right? From here to here, from here to here, or it might be from here to here, from here to here, and then they are asking you to find this one. That is where you use the Pythagoras theory. And then for the trigonometry, you are giving one of the angle where you are hiding, right? And then make sure that once again you watch the video to the end. Then I'll solve example for you to have a pure understanding here. Now, the work of the Pythagoras theory, as I just explained here, is what that rule says what the hypotenuse squared is equal to a squared plus what the opposite squared, right? So this is just a 2. This car here will lead us to what the third place, or this guy will help us to determine the distance for what the third place. Okay, now this is very simple to understand. Is that okay? You just need to understand the meaning of this guy. That's the hypotenuse square is equal to the a square plus what opposite square. Some book use what c square, that is equal to a square plus what plus b square. You just need to understand the names, right, where they are coming from. Okay, now let's see how we can use these things to solve this type of a problem here. Now here's the problem. They say if sine x, right? So this sine x here is equal to 3 over 5 when 0 degrees is less than or equal to x less than or equal to 90. So what it means is that where you are hiding is between this angle, right? So where you are hiding is between this angle, so from 0 degrees to 90 degrees, and then we are giving this sine s. Now you know sine is equal to the opposite over the hypotenuse, right? So opposite over the hypotenuse, that is the sine there. Okay, now let's say without using a calculator or a table, you should evaluate this, right? Evaluate this guy. You are going to evaluate cos s plus tan s, everything divided by sine s, right? So this is another distance they are asking us to find. Now these are the information that we are giving. We know that this guy is sine s is equal to, so as I just explained, I said this guy applies to the right angle triangle, right? So the right angle, so obviously we know that the triangle that we are dealing, or the distance between the three of you, forms what a right angle triangle, right? So right angle triangle, and then we are given sine s to be equal to 3 over 5. You and I know that sine s is equal to opposite to over what hypotenuse, right? So that this is one thing you have to know. Okay, now where you are, that one is your own palaver, right? So maybe assuming you are here, assuming you are here, so this guy is here, and then you are giving sine s to be equal to 3 over 5. You know that sine is equal to opposite, so if you are here will be your opposite, which is 3, right? So here will be on the top one, that is what 3 over 5. This is what we are giving. Is that okay? This is sine s is equal to opposite over hypotenuse. So opposite here will be what 3, and then the hypotenuse here will be what? Will be 5. Right? So this is very, very important. So you need to know these things, right? So if you are here, this will be opposite. Then the longest side will be your hypotenuse, and then the one down here will be what? The adjacent. So clearly you can see that we are not giving what? The adjacent. Is that okay? So we can call it what? A. Right? So let's call it A. Just the initials of what? Adjacent. Now, they say you should find this guy. So we need to know the cos s, we need to know the tan s, we need to know the sin s. The sin s there it has already been given to us. So let's go and locate what the cos s is. So how do you know the cos s? The cos s is equal to the adjacent over hypotenuse, right? So from this diagram here, you can see that we know the distance from here to this place here, and then we know the distance from here to here, but we don't know from here to this place. So we need to find this guy. So which two are you going to use here? So here, straightforward, we can use what? The Pythagoras Theory. Is that okay? So because we are given two sides here, so we can easily determine the this side. So we need to know the A, adjacent, before we can write down the definitions of what these guys here, right? So before we can write the definitions of this guy, which says the adjacent over hypotenuse, and then the tan x is also equal to opposite over. You can use this simple trick here to remember the definition. So you call it what? SOHCAHTOA, right? So and then 12, right? So this is a simple name, SOHCAHTOA. So sine is equal to opposite over hypotenuse, and then SOHCAHTOA. Cos is also equal to adjacent over hypotenuse, and then tan is also equal to opposite over hypotenuse. So this is just a simple analogy here. Okay, now let's look at the A here, which is what the adjacent. Is that okay? By using the Pythagoras theory. So now using the Pythagoras theory, we know that the Pythagoras theory says that you should have the hypotenuse squared is equal to the A squared plus what? Opposite squared, right? So the adjacent squared plus the opposite squared. So we are given the hypotenuse from the question, that should be 5. So 5 squared here is equal to A squared, which we don't know, plus the opposite was what? 3 squared. Is that okay? So do your calculation perfectly. You should arrive at the point where you are having what? 25 is equal to A squared plus 9 squared. So we are going to subtract 9 from both sides, right? So or you can take 9 to the other side of the equation. That gives 25 minus 9 is equal to A squared. Is that okay? So A squared, we are looking for A, but not A squared. So what do you have to do here? Give a 16. 16 is equal to A squared, right? So you take a square root of both sides. So taking the square root of both sides, that will give you 4. Right? So we have the adjacent here to be 4. So boom, we are good. We are free to move on here, right? We are free to move on. So you have the adjacent to be 4. So if the adjacent is equal to 4, what's next? Now that we have the adjacent here to be equal to 4, you can easily write down all these things. So this is what they are asking us to evaluate, right? So we know this. We are looking for this here and then this guy. So the cos s will be adjacent over hypotenuse. So adjacent was 4 over what? Over the hypotenuse, which is 5, right? Which is 5, and then the tan s2 is equal to opposite, that is 3 over what? Over what? The adjacent, that is 4. Right? So these are the 3 guys that we are going to use, and then plug in into that and do our calculation very, very simple. So okay, so this guy here, we are told to evaluate this cos s plus what? Tan s, right? Tan s, everything divided by what? Sine s, right? So this is what we are just going to replace. The cos s, we had 4 over 5. So 4 over 5 here. Remember 4 over 5, and then plus what? The tan s, which is equal to 3 over 4 here, and then everything divided by what? The sine. So the sine, we are giving that in the question, that is what? 3 over 5. Is that okay? So you just need to manipulate this and then write your answer. Make sure to just pause the video and then come back and check on your solution. Okay, thank you for doing that. So if you manipulate everything, you should have something that is equal to 31 over 12, right? So this is what? An improper fraction. So that will give me a 2 whole number, 7 over 12. If you're having a different answer, just make sure that you comment down below. But if you don't know how to do this, and this is the fraction, so at the top here you have to find the LCM, right? So you find the LCM out, and then when you are done, then you divide by what? This method here, right? You divide by this guy at the down here. If you enjoyed this video, don't forget to subscribe to our YouTube channel for more content on it. Thank you for watching.